Alright guys, so welcome back to the channel again. Today we're going to be talking about L'Hopital's rule for solving limits. And this can be very useful in classes like AP Calculus, especially when they never ask you how specifically to solve limits when given an indeterminate form. So this is a quick, very easy way to solve those type of limits and can help you out a lot. So what is the rule? First, let's talk about that. This is the problem. Let's talk about the rule. The rule states that if you have a limit as x approaches c of a function, let's just say f of x over g of x, has a numerator and a denominator, two separate ones, right? And when you solve it out by direct substitution, you get 0 over 0, infinity over infinity, or negative infinity over negative infinity. Now these three forms are called indeterminate forms. Now, something about indeterminate forms, basically when you tell yourself in class, I got an indeterminate form, what do? It basically just means you got to solve a little, work a little harder to get the solution, right? You just got to solve a little more and get the solution. So, L'Hopital's rule states that if you have a limit as x approaches any constant or any integer c of f of x over g of x, and you get any of one of these three indeterminate forms, you can use the rule. Now, what's the rule? This is the criteria, right? Now, what's the rule? It basically says you just take that same limit and now apply it to the derivative of each, the numerator and the denominator. Now, if you don't get your answer by now, and you still get one of these indeterminate forms, you can do it again. Take the second derivative. And each time you're applying that same limit, and you'll get the answer eventually. It could take 100 tries, it could take one try, you know what I'm saying? So now let's talk about this solution and how you can solve this limit. Let's plug in direct substitution, right? Well, what's negative cosine of pi over 2 over pi over 2 minus pi over 2? Cosine of pi over 2, if you know your unit circle, I'll talk about that in another video, that's 0. Negative doesn't matter, it's 0. Pi over 2 minus pi over 2 is 0. Now what does that look like? That's a direct substitution, and what do we get, 0 over 0? That's an indeterminate form. It means we can solve it, and let's use L'Hopital's rule to solve it. In my opinion, it's the easiest way to solve one of these problems if you get indeterminate form. So, first thing you do, let's look. Derivative of the numerator, derivative of the denominator. The derivative of cosine of x is negative sine. So the derivative of negative cosine would be positive sine. So it's sine of x over the derivative of x minus pi over 2. Pi over 2 is a constant value. Pi is not a variable, it's a constant. So x minus pi over 2, the derivative of that with respect to x, well, it's just 1. You do power rule on that x, right? You just get 1. Sine of x over 1. We just plug that same limit as x approaches pi over 2 on this, and what do we get? Sine of pi over 2, unit circle, that's 1, and that's 1 over 1. So our answer is just 1. And looks a lot more complicated when you look at it up here. You get indeterminate form. L'Hopital's rule can simplify that out, especially when you have a single variable x, and it can make your life a lot easier. Now let's look at another problem. Alright, so here we're given a limit, the limit as x approaches 0 of e to the x minus 1 over 2x, and that's problem 1. We got problem 2 right here. So how would we solve this using L'Hopital's? First, we're going to need to check that we can use L'Hopital's rule. That's the first thing you always do. You plug in the limit directly. So let's plug the limit in directly. E to the 0 minus 1 over 2 times 0. This is just going to give you 1 minus 1 over 0, or 0 over 0. And that is indeterminate form. And that meets our criteria for using L'Hopital's rule, because it's indeterminate. And once we get one of those three forms, we can actually put it in and plug in and use L'Hopital's rule. So, L'Hopital's rule states that if we have indeterminate, which means we have do, so check. If it's check, then we can use the rule. And let's use the rule, which is derivative of top or derivative of bottom. Derivative of the top would be derivative of e to the x, which is just e to the x, and derivative of the constant, which is just 0. So the derivative at the top would just be e to the x over the derivative of the bottom, which would just be 2, because 2 times x, derivative of 2x is 2x. I mean, it's 2. And now you plug that limit in. That same limit. You're going to get e to the 0 over 2, and which is 1 over 2. E is a number. Any number to the power of 0 is 1. So that's why our answer here is 1/2. 1 over 2. Remember, always plug in the limit directly, and if you get an indeterminate form, that means you're able to use L'Hopital's rule in the problem. Alright? So here, let me do the second problem here. Okay, the limit as x approaches 0 of sine x over x. Looking at this limit seems almost impossible to do regularly, unless you use like the squeeze theorem or something like that, I don't know. But it's very easy when you do it with L'Hopital's rule. First thing we're going to do, obviously, check if we can use L'Hopital's rule. We're going to plug in 0 over 0, sine of 0, and our unit circle, that's 0, and over 0, which is indeterminate. So it passes the indeterminate test by direct substitution. Since our limit passes the indeterminate test, then that means we can use L'Hopital's rule, right? So derivative of the top over the derivative of the bottom. Derivative of sine of x, we know that's cosine of x. That's our derivative of trigonometric functions. Over derivative of x with respect to x is just 1. So we plug that limit again of this, and we're going to get cosine of 0 over 1. And cosine of 0, unit circle, you know that is 1. So that's 1 over 1, and our answer is 1, using the L'Hopital's rule, right? So, yeah, these are just some problems for L'Hopital's rule. If you guys want to learn more about L'Hopital's rule, how it works, you can search up videos online on Khan Academy, on any online forum questions or whatever. These questions are from Khan Academy, and I think they are good exercises for learning L'Hopital's rule. So if you enjoyed this video or want me to answer any questions, feel free to ask me.